So I actually have a whole nother example in the slides that I'm not going to go over, but the answers are all worked out in the slides, and so you can go back through and do the calculations yourself. But I wanted to just sort of summarize what we're talking about. We've talked about order, right, and overall order, right? So if I have this reaction that's here, oh sorry, pointing at the wrong screen. The reaction that's here, and we have an experimentally determined rate law, right? The reactant orders are first order and half order. Okay, so reactants orders are first order in CHCl3. That's actually chloroform, and then half order in chlorine, like that. Overall, right, the reaction order, so the reactant orders, but the overall order, the reaction order, overall order is 1.5. All right. Just a couple of things to remember, right? Zero order reactants, if the concentration does not depend, if the reaction rate does not depend on the concentration, you know automatically that it's zero order. And you'll know that because it's a straight line, right? That is, it's not changing the slope as time progresses, and so you'll know it's zero order in that case. We're going to be doing a lot more stuff next week about this, but for now, this is what I want to go over. Now, rate constants, right? Rate constants are not concentration dependent, but reaction rates are. And what I mean by that is that we know that rate, right, is equal to k times and then something over here to something over to the exponent, right? This is the rate constant. The rate, reaction rate, is concentration dependent, but k is part of that same equation, so it's not concentration dependent. And you can sometimes have negative reaction orders. That means it actually goes faster as you remove it, okay? And that's actually mostly seen when we talk about something called product inhibition, where sometimes in the rate law you get something from the product that slows down the reaction. This is something that you see in biology a lot. It's a sort of homeostasis kind of thing. It's a way to maintain or self-regulate. And so some of these products will actually be part of the reaction, but in terms of not reactants and products, but in terms of, they are part of the products, but they're not in terms of like the reactants, but they're actually slowing the reaction down by being present in the solution where it's made. So anyways, you can have negative orders. We won't see any in this class. I'm just telling you, when you like move on and become a biochemist or something, or do biology and do a little kinetics there, maybe you might see like the order is negative or overall negative because it's an inhibitor of a reaction. Okay, so that's the summary of this week's unit, and next week we'll finish this chapter.